Hello and welcome to Today I Learned Climate. I'm Laur Fisher from MIT, the Massachusetts Institute of Technology. And today we're digging into a question sent in by Robert P. of New York, who asks, why have electric vehicles won out over hydrogen-powered cars? Which is an interesting question because there was a time when hydrogen and electric cars were pretty evenly matched as clean alternatives to gasoline-powered cars. In fact, just 20 years ago, hydrogen-powered vehicles were a signature initiative of then-President George W. Bush.
Tonight, I'm proposing $1.2 billion in research funding so that America can lead the world in developing clean, hydrogen-powered automobiles.
But today, EVs are way ahead. The big car companies are rapidly electrifying their lineups, while only a few hydrogen cars are available. But first, let's clarify the difference between a hydrogen-powered vehicle and an electric vehicle. Now, okay, this is cool. Technically, both EVs and hydrogen-powered vehicles are electric. They're both powered by an electric motor, but they work in two different ways. The ones we call electric vehicles, or EVs, have batteries, and they get their electricity from the grid. You charge the battery by plugging the vehicle into a charger or an outlet, kind of like charging a phone. Meanwhile, a hydrogen car can make its electricity while it drives. Hydrogen vehicles have something called a fuel cell. If you're trying to picture it, it kind of looks like an engine. You fill the car up with liquid hydrogen, which runs through the fuel cell.
A simple chemical reaction between hydrogen and oxygen generates energy, which can be used to power a car, producing only water, not exhaust fumes.
Thanks, Mr. President. Okay, so knowing that, to help answer your question, Robert, we talked to Sergey Paltsev of the MIT Energy Initiative, where he's a senior research scientist who studies the economics of clean energy technologies. And the really big reason that EVs have taken the lead, he said, is cost.
About 20 years ago, hydrogen cars were very promising. At that time, they were probably about equal in cost to battery electric cars. And people were asking, which one is going to win? Because the batteries at that point were very, very heavy and very, very expensive. But battery costs went down substantially now.
Yeah, 20 years ago, it was far from guaranteed that we could make batteries that were large enough to drive on for more than a few miles, or cheap enough to mass manufacture, or light enough to put in a car. So it matters a lot that we figured out how to make cheaper batteries. How much cheaper? Well, over the past 15 years, lithium-ion battery prices have fallen about 90%. which has let a growing number of car companies sell electric vehicles for less than $30,000. Meanwhile, hydrogen fuel cells just haven't kept up. The two mainstream hydrogen cars available in the US today, the Toyota Mirai and the Hyundai Nexo, start at $50,000 and $60,000 respectively. Hydrogen cars are also more expensive to drive. Dr. Paltsev and his students recently did a study on the lifetime cost of ownership for a hydrogen fuel cell car compared to a traditional gas-powered car.
Basically, we look at the questions, how much does the car cost? What's the maintenance cost? What's the cost of car insurance? What would be the price of the fuel? And when you add it all up, hydrogen is still like 40% more expensive in terms of the total cost of ownership. Well, of course, some people may want to make a statement and spend 40% more on car, but an average person most likely is not going to go that route.
Meanwhile, the same study found that the total cost of ownership for an electric car is getting closer to a traditional gas car, in large part because electricity is cheaper mile per mile than gasoline. That's just not true of hydrogen. If you've listened to our Season 4 episode on hydrogen, you know that we have to make hydrogen out of something else. Today, we mostly pull the hydrogen out of natural gas, which is a fossil fuel. We call that gray hydrogen. But this process creates a whole bunch of CO2 and other climate pollution.
We really need to run these cars on green hydrogen.
He doesn't mean it's like a green-colored gas. It's a shortcut way of saying that we use clean electricity to extract hydrogen from water. We'll cover this process in much more detail in next week's episode, so stick around for more about these hydrogen colors. Nevertheless, there's not much green hydrogen on the market, for cars or for anything else.
Hydrogen is still very expensive. The cost of production of hydrogen is indeed getting lower and lower, at least for green hydrogen. But that's only part of the story, because it's not only about the production costs. We still need to transport that hydrogen somehow to gas stations or hydrogen stations, and you still need to store it. And that's not cheap.
Which brings us to the second big leg up that EVs have over hydrogen cars. A vast nationwide electrical system already exists. A full transition to electric vehicles creates big challenges, including the need to build a charging network and make plenty of extra electricity to power all these cars and trucks. But it can all build on our existing electric grid.
You don't really need to create another infrastructure for electric cars. Most electric vehicles are used in cities where you charge at home. If you want, you can avoid all the supercharges and be fine for shorter trips. With hydrogen, you are not able to do that. So, for example, how can a hydrogen car compete in Massachusetts if there is no single hydrogen gas station for private cars in Massachusetts? Where would I fuel that car?
Here in the US, you can really only find hydrogen filling stations in California, and even there, pretty much just around San Francisco and Los Angeles. Other countries like Japan, China, and Germany have many more of these stations, so countries can certainly provide their drivers with hydrogen if they're motivated to, but it is a lot more infrastructure to build. Even given all of this, it's still worth looking at the advantages of hydrogen-powered cars. For one, it's a lot closer to the pump-and-go experience that everybody knows from using gasoline. And, like gasoline, hydrogen packs way more energy per pound than a battery does. That means it's really useful in something like heavy-duty trucking, which needs to carry a lot of weight a long distance between refueling stations. So, Dr. Paltsev said that he can imagine a scenario where we turn to hydrogen for our big, long-distance freight like trucks, and then it becomes easier to plug smaller hydrogen cars into that infrastructure.
If we go the hydrogen route with heavy-duty trucks, then that is going to give some positive spillovers for the light-duty segment. At this point, it doesn't seem like a high probability, but at the same time, I wouldn't say, oh, hydrogen has lost completely. There is no really zero-emission solution for transportation so far. And so, when you compare different modes, you need to understand, okay, what are the different cost impacts? What are the economic impacts? What are the consumer preferences? It looks like at this time, electric cars are winning. And we will see how that is going to evolve into the future.
Robert, I hope this answered your question. But if you have more questions about EVs, like about their climate impact, given that we currently generate electricity mostly from fossil fuels, or the impacts of mining for EV batteries, or how much we should weigh EVs versus public transportation, then check out 2 really great episodes that we made called TIL about electric cars and TIL about everyday travel. And if you have a question for us about climate change that we haven't covered, whether it's simple or sticky, about science or solutions, then ask us. We have a few different ways you can do this. You can visit climate.mit.edu/ask. You can email us at climate@mit.edu, or leave us a voicemail message at 617-253-3566. We'll be releasing answers as episodes here on TIL Climate, as well as online at tilclimate.mit.edu. We look forward to hearing from you. TIL Climate is the climate change podcast of the Massachusetts Institute of Technology. Aaron Krol is our writer and producer. David Lishansky is our sound editor and producer. Michelle Harris is our fact checker. Sylvia Sharp is our climate education specialist. The music is by Blue Dot Sessions, and I'm your host and executive producer, Laur Hesse Fisher. A big thanks to Dr. Sergey Paltsev for speaking with us, to Andrew Moseman, who did the original reporting for this episode, and thank you for listening.